My previous recording was interrupted, so this is going to be part 2 of my communications from Chapter 1 of the Year 11 textbook. And I'm going to be looking through what you go through in Year 11 to some extent, and a little bit of an extent of what the finished end goal will be for Year 12. I'm not going to go through everything. I'm not going to go through developments, for instance, but it'll give you a pretty good overview. First thing I wanted to talk about is the third angle projection symbol, which looks like this. Like I said, I consider this a target and a flag. The actual idea is it's a cone shown, and to show that it's a cone, we have to include these lines here. We're going to talk about those lines in a second. They're called center lines, which I guess brings us back to line weights. And there are two line weights. There's thick dark and thin dark lines. We might draw lines initially as what we call construction lines. They should be drawn with a 2H pencil. Now, I have always, when I was going through high school and uni, I always just used the same mechanical pencil for all my drawings. I was lazy, and I never used a sharpened HB, and I never used a sharpened 2H. If I wanted to draw a construction line, like my working out lines, my lines that I'm going to use to start off with, what I would do is I would just draw very lightly on the paper. And if I wanted a thin line, I would hold my pencil at a very steep angle, like a 45-degree angle or lower, and just use the corner of the pacer, the mechanical pencil. And if I wanted a thick dark line, I would use I'd hold the pencil flat. So the idea here is that you can see this drawing here talks about how the difference between holding the pencil flat, we get the full 0.5 millimeter. Whereas if we hold it on the side, initially we're going to get a very thin line, but as time goes on, we'll get a wide line. So just looking at your pencil and seeing how the graphite is moving away was how I controlled it without having to use multiple pencils. The official thing that I recommended in the previous video is that you're supposed to use, where I've drawn blue lines here, my very light lines, that should be done with a 2H pencil that should be sharpened. The thick dark lines that I've shown here in black, they should be done with a mechanical pencil that's 0.5. Now, I did look in the Australian Standard. I can't find anything that specifies 0.5. I will just tell you that that's what I was taught, and I don't think you're going to go wrong in the HSC if you use 0.5. Then you're going to have to use thin dark lines, and you're going to use thin dark lines for things like center lines, for dimensioning, and for hatching or sectioning, which you can see there. And in this drawing, I've used red. For that, you should be using a sharpened HB pencil, or if you're like me, you can just use the edge of your mechanical pencil. So let's go back to the standard. Now, this is the VCE, the Victorian VSC, Victorian. I don't know. The equivalent of the HSC in Victoria, their document, anyway, they have a pretty good document, and they talk about, so there's 4 different line types. The thick dark lines, which you can see here, I've drawn as a black line on the whiteboard. The thick dashed lines. Now, I don't have any thick dashed lines there, hidden detail, but if I was drawing hidden detail, it would be in the same black line. Then we've got thin continuous, which is used for dimension lines, which you can see I've done in red. Also for section lines, for center lines, and for sectioning and hatching. And then we have the thin chain. The thin chain is what we use for, I take that back. The thin chain is what we use for center lines. So that's a long line, short dash, long dash, short dash, long dash, short dash. And what that does is it shows that something is circular or cylindrical. So we use that a lot to show that, so that we can see when we look at this sideways, so that we don't think that it's a rectangular shape. We show it as being, we show that it's cylindrical by having a center line on it. And that's how we indicate that in our drawings. And that's very important. You'll definitely lose marks. Maybe not in the HSC, but you'll definitely lose marks with me if you don't include center lines. So if we go back to, well, we've already looked at the Copeland section. We're going to continue on. The next thing to talk about is dimensioning. So we said that dimensioning should be done with thin dark lines, so a sharpened HP. And there's some things that we should specify. Well, first of all, that the Australian Standard says that we should use arrowheads that are solid, they're 3 millimeters times 1 millimeter. So that means that they are 3 millimeters long and they're 0.5 millimeter each side of the line. And that's how we should draw them. Now, the reality is it's hard to draw a solid shape on paper when we're drawing with pencil. So instead we just draw the outside. We don't fill in the arrow. Now, there's also what we call the standoff, the gap between that dimension line and the object. That should be 1 millimeter away. And then we also have little lines that extend past, and I think that they should be 2 millimeters past the dimension. The other thing that we need is really important is that when we're drawing our dimensions, you notice that the dimensions are always written above, right? So here we don't really have a great counterexample there, but they're always written above the line and to the left. Can you see how this is written above the line and to the left of the line? And this one is also written above the line and to the left. A lot of people want to write the dimension here, but if you do that, it can be confusing. If you write the 10 here, it could be confusing as to whether or not the 10 is here or here, especially if you're reading on a wet day and you're running late and people are, they're running out of money and we're very cranky. It can be very easy to make those sorts of mistakes. I would say that your dimensions, and this is really critical for the drawings that you do for me in your civil engineering report at the end of the year, it's important that you round off to the nearest millimeter. Unless you are specifying something with greater accuracy, unless something is, like a space shuttle where you've got a tolerance of 1/10 of a millimeter or something like that, I would say that unless you're specifying otherwise, we always show all dimensions in whole millimeters. So unless we specify otherwise, all dimensions are in millimeters. It's never going to be in meters or centimeters or anything else. We always use millimeters unless we specify otherwise. Okay. So yeah, the arrowheads, they can be open or solid, and always touch but do not cross the projection lines. So these lines here, they're called the projection lines. Now, in other videos, I've talked about how engineers in actual practice when they're drawing sketches might be lazier, but this is for official drawings and this is the standard you should be working to. Okay, for circles, it's a little bit more complicated, but here we can see the hidden detail lines, and we can see the hidden detail lines are in thick, dark lines. They're thick, dark, dashed lines. And what that does is it shows the viewer that there's a circle running through this space and that there's a recess. We can see the recess here, and then there's a circle running through that space. So we can tell that this area here is circular because it's got a center line. That center line, which is a thin dark line, and it's a chain, which is long, short, long, short. That shows us that this is circular and not that it's a rectangular cutout. Okay, so I'm not going to go into dimensioning of circles at the moment. I'm going to go instead, I'm going to move this and go to some drawings. Okay, so here we have some drawings. What I'm showing here is don't ever write your dimensions on this side of the line. That would not be to the left. Like Beyonce says, to the left, all of your dimensions to the left to the line. Anyway, you can see that in this shape here, can I zoom in on that? Probably not. That I've written above the line in both cases and to the left of the line. What else is going to... Okay, so I was saying how often engineers, they often draw their arrows like this. They often draw their arrows just as a slash at 45 degrees. Yes, you can do that if you're an engineer who's doing a quick sketch and you're handing something over to someone else to draft officially, but you would not be allowed to use that when you were handing it over to your client for your formal drawings. Your formal drawings will have to be done as a correct arrow, which is 3 and then 1 millimeter wide. It's important to remember that. So how a lot of people draw this is they start at where the dimension line meets the projection line, and then they draw out. And by drawing out, they often get a curve that goes this way, and that's probably more correct. If you had to take a guess, a lot of people, when they start learning, they draw like this, and that's probably not ideal. You're better off taking it in from where they meet and then taking it out. Okay, so this gap where the dimension line meets the drawing, if you saw the Victorian thing, it said that should be 1. I'm happy to agree with that. The distance, the minimum distance from where your projection lines should be 10 millimeters, but it can be multiples. So if you have multiple dimensions, you might go to 20 or 30, something like that, but I always work to the nearest 10. We've talked about how the arrows should be 3 millimeters wide, and 3 millimeters long and 1 millimeter wide, and the projection line should extend by 2 millimeters. These are all things that you need to set in AutoCAD. I have another video where I talk about how you can set those specifications on AutoCAD. The next thing probably worth talking about is, well, there's a sign called a centerline sign. So a centerline is a long line and a dot, or a short dash, long dash, short dash, long dash, short dash. They call that chain is the terminology for that. Okay, so that covers most of the things. The one thing I'll talk about is text. Now, when I was learning in high school to do drawings, we were always told to make our text 4 millimeters tall, and it should always be in all capitals. The idea there is that we would work with a 10 millimeter block, and in a 10 millimeter block we'd draw a line 3 millimeters either side, which left 4 millimeters left over, and that gave us text that was 10 millimeters tall. Now we did that because it was easier to specify, and it also happens to be sort of in the middle of what we're going to do. So we're going to talk about the AS1100 does specify text. If you can see here, the VCE says that your title blocks should be 5 millimeters tall, and I agree with that. We'll have a look at that to the AS1100. We've now switched over to the AS1100, and the AS1100, it specifies different line types, and it says where they should be used, and it shows how you should draw your thin dark, your dashed lines, and how you should draw your chains, and they specify minimums so that the spacing should be at least 1 millimeter, and your thin dash should actually be more than a dot. Sometimes I just draw a dot, and you shouldn't. It really should be 2 millimeters. But anyway, we're going to go. The sizes of your text, if you're drawing on an A4 piece of paper, your titles should be 5 millimeters. Your subtitles should be 3.5 millimeters, and your general notes and materials lists and your dimensions should be 2.5 millimeters. So that's the AS1100 for sizes. That said, if you did everything to 4 millimeters, I'm going to give that to you correct in the HSC. So I'd think it's better to know what the right thing is, and then you can ignore it. Okay, so now that we've talked about hidden detail, we can go back up to here and look at this document. Okay, so we've talked about dimensioning. So the next thing to talk about is, do we want to, yeah, okay. Okay, I'll talk about circles in a second. While we're talking about hidden detail, so we can see the importance of hidden detail and being able to identify our drawings here. So if I ask you to find match 1, where does 1 match to? Well, we said earlier that that was E. And we can see how there's hidden detail that when we look through the side, we can't actually see that this goes in. But in order to be able to indicate that to people, we can use hidden detail. Now, as we go on, we're going to use hidden detail less and less, and I'll talk about that in a little bit more detail later, but a little bit of a detail pun for you. But the idea is that we will use, instead, we'll use something called sectioning. And sectioning is imagining that if you just cut away part of the shape and you show them what it looks like when you cut away part of the shape. We'll go back to, well, did I delete that picture? Did I close that picture? I maybe want to keep that. Yeah, I'm going to keep that. Okay. Okay. So just to pick something interesting, let's go through just 2. Which one is 2? Can you guys match up where 2 lines up with? Well, when we look at 2 from the top view, we can see that it's going to be 2 steps long from the left, but it doesn't go. It's B, D. D looks okay. The problem with D is that it's on the wrong side. H looks good. Yep, H is good. H is the thing. And so when we're looking from the side, if we're looking from the direction of the letter H, we won't be able to see this little groove. And because we can't see this little groove, they need to show that in hidden detail. Okay, what about 3? Can you match up 3? Yeah, L. It looks similar to D, but the difference between it and L is that for some reason it's got 3 hidden lines of hidden detail. D only has 1 line of hidden detail measured from looking from the direction of D. But when we look at L, looking from this direction, we can see, well, we have a hidden detail for this bay area, this cut, and we also have a hidden detail line here from the other side where this drops down. So it's going to give us 2 hidden detail lines, and that explains 3. I won't go through any more because otherwise my homework won't be as useful. Okay, so we're going to move on, and we're going to talk about how to dimension circles. So when we dimension, I've said before, we always write above the line and to the left. I've said here that we never write on this side. This side would be wrong. Yeah, we always write this side, not that side. Okay, so if we continue, we can see here that dimensioning circles is a little bit more difficult. When we're dimensioning circles, we can use the symbol for diameter. This symbol here, it looks a bit like a Danish letter for but it looks a bit like a Danish symbol, but it's the diameter symbol, and the diameter symbol is a circle with a line through it. And so one way that we can specify, that we can say that this sort of knob, like a doorknob or a bed knob shape, we could just say that this is 30 with a diameter, and that's all we need to specify. We can tell that it's circular because it's got center lines. Now you can see my center lines are dots, and we've learnt that center lines should always be at least 1 millimeter. But you know, I hadn't remembered that part of the standard when I did it. Okay, the next thing is we have nested dimensions. Can you see how this 20 is inside the 70? The idea is that the smaller ones go inside the bigger ones. So that's fine. But remember when we talked about how the distance for this projection line should be 10 mil, and this one here, the projection line would be 20 mil, because there should be multiples of 10 millimeters. Okay, for small areas, I can't really write anything in this space. It's too small. So what I can do is I can use an extension line, and I can draw out like this. And that's a way of, and whenever we draw an extension line, that could be for an arrow when we want to label things, or if we wanted to mention it, it should always go up, and then when you've reached the right spot, it should go across horizontally, and that makes it much easier for the person to read. So they can then see, oh, this 20 is associated with this line. If it just comes straight out, it can be very hard to know which dimension that relates to, whereas this line helps us to know, oh, it relates to that dimension. Okay, if we have something that's bigger, what we can do is we can just write the dimension inside the circle. Now, we typically don't want to use some things that are exactly 90 degrees or 45 degrees. 30 degrees is okay, though. So we can draw a 30 degree line across the circle, put arrows on either side, and then just write 40 diameter on the inside. Then for this circle, you can see it's too small to fit anything in. So because it's too full to fit anything in, all I've done is I've just drawn an arrow, right? I don't have these 2 arrows here. I'd ideally like to fit those 2 arrows in here, but we wouldn't be able to fit 2 arrows in there. So instead we just have 1 arrow touching the outside, but it needs to be pointing to the center. Yeah, it needs to be pointing to that center where those 2 center lines meet. And we draw that out and across, and then we write 10 mil diameter. And then sometimes we have radiuses. So this is or a radii. This is a radii or radius, and that radius is 5 millimeters. And so we do the same thing. We just make sure this line points to the center of the radius, and then it goes flat. And if we just write R, that's enough to indicate to anyone who's reading this diagram that they'll know that R stands for radius. So that's how we dimension circles. So this is written. This is specified on page 20. Oh, I said 20. It's actually on page 23 of the VCE document. And you can see different ways of specifying dimensions. All good? You notice that one's actually looked like it was at 45 degrees, but anyway. Page 22, I'm going to edit that. And it's also specified on page 95, all dimensioning is specified on page 95 of the Australian Standard, which so for circles, this is where it's specified in the Australian Standards. They have some other stuff. So from page 95 on. You can see I've obviously not photocopied. I'm not allowed to photocopy the whole thing, but I've taken the parts I think are important. So here we can see nested dimensions, and there's the dimension sign. Here's another some examples where they've shown some more details. It's important that we include the center line so that we can see things. And here's some more dimensions. Okay, so we can close that. We've done that now. Okay, what you're allowed to bring: a pair of compasses, a protractor, set squares, circle templates, including isometric or ellipse templates. We've talked about that. We've talked about why we want to use HB pencils and sharpeners for our thin dark lines, for our dimension and center lines. We want to use a pacer with HB leads for our thick dark lines and for our hidden detail. We want to use a 2H for our construction lines. And if you watch my video, the toaster video, you'll get that. Here we can see the difference between circle templates and ellipse templates. Be really careful when you buy them. The Kent ones I know work, but some of them they can. I remember having some real problems with why doesn't this dimension work? And this orange one here, I'm pretty sure it doesn't work. The dimensions that are listed are from this distance to this distance, and that's not what it should be. If you're drawing with an isometric drawing, you want the dimensions to be sort of 45 degrees, like crosshairs. Let me show you that. I mean, I guess these look like crosshairs. The lines that we're measuring are from here to here. So when this says 50, that's because the line is from here to here. Here to here is the 50. Okay. So that's what we're allowed to bring. We've already looked at circle templates and things. Okay, so the next thing to talk about is threads. We don't go into a whole lot of detail on threads in year 11 normally, but in the past I used to say if it's not in the Copeland textbook, it won't be in a test. These days I feel as though I don't have enough good questions in the year 11 textbook to test higher students. So I am now including a little bit more detail. So even things up to reactions and maybe even some introductory to trusses, some things like shit. Not relevant to this video. Anyway, the point is that we don't draw threads like they look in real life. You might say, why not? They look, that looks a good drawing. Really, really, really hard to draw that. It would be very time consuming to draw that. So instead of drawing this, we don't draw this. We don't draw a thread that looks like a real bolt. Instead, what we do is, I want to point this out. No, do not draw this, right? This is wrong. And every year I get a kid who draws that. Instead, we should draw this. Now, these should be thin, dark lines. These inside lines should be thin, dark lines because they're hatching. And this is how we draw bolts. Now, the distances here, look, that's something we go into a lot of detail later where we learn about coarse bolts, coarse and fine threads. And we're going to go into a lot of details later. But for the moment, I want to give you the very basics, right? Now, when we're drawing the bolt, so this is the bolt. If we looked at the bolt from the head, it would just look like a hexagon, right? That makes sense. Whereas if you look at it from the bolt side, how we draw that is we draw that with the broken line on the inside. Now, how I like to think of this is the broken line only goes where there's metal, right? So because the bolt is made out of metal, what we did is initially we had a bolt and then we cleared the bolt and then we cut something, we cut through here with a die, and then the die cut away and shaved off metal. And so this is the line of where we've cut away metal. If we're drawing the bolt, that's how we draw the bolt. If we're drawing a nut, so the nut goes on the bolt. Well, in this case, if this is the nut that we're looking at, if we're looking at the nut, what we're going to see is the broken circle is going to be on the outside. And the reason the broken circle is going to be on the outside is because that's where there's metal. There's nothing here. If this area is empty, there's nothing here. So the broken circle goes on the outside because when we use something called a tap to cut through the inside thread. We tap the nut is how I remember that, like Johnny Cage. Anyone who's played Mortal Kombat, he occasionally taps the nuts. And if you're a Barbie and Tchaikovsky song fan, you might say the akkaka. Anyway, bit of an inside joke there. Okay, so what we do is we tap the nut to cut the outside out. And this is where the part that we've cut out is. And so that's why we've got a broken circle to say part of that has been cut away. And that's inside the metal. Okay, broken circle, nut outside, bolt inside. Okay, yeah, I guess nutting outside could be, remembering that might help you. Okay, so that's all I want all the detail I want to go into here. There is some dimensions that you will have to learn, and maybe I will get to this by the end of the Year 11 course. You need to know the head of a bolt is 7 times the diameter of the bolt. Sorry, 0.7 times the diameter of the bolt. The thickness of the nut. You know what? That's too much for this video. We'll cover that in greater detail later. Okay. This is just the same thing. So I don't need to go into that. Okay, this is a student drawing. That I think the student, so it demonstrates, it shows some good concepts that we want to look at. I wonder if I can just copy image address. I should have done this earlier. Okay, so if we look at this drawing, it is side on, which is not ideal, but let's have a look at how I feel about these, this drawing. So we can see that there's hidden detail, a lot of hidden detail, and there are center lines to show that this hidden detail is circular. It's something has been drilled out of that area. That's fine. I'm happy with that hidden detail, those things. The only thing I'd say is that the hidden detail should be a thick, dark line as per the Australian standard. That's okay there. Over here, generally, so what we've shown here, this is the same drawing, but what it is, it's imagining instead of showing it from the outside and we're using hidden detail as like an X-ray, what we're doing instead is we're imagining if we just took a saw and just cut it in half. And then these lines, what we call this hatching, or these section lines, they show, well, hatching is the proper term to use here, they show the area where the saw has cut through the material. And they show us that here, there's nothing in this area is empty, and that this area here has been cut through by the saw. Now, what we generally do is we don't include hidden detail and sectioning, right? We don't use that and hatching. We don't combine them, right? We use instead a process called PCD, pitch circle diameter. I'll go into that in a little bit in a second. The point is we just generally don't combine the two. We either don't include it at all and we show it somewhere else, or we move the interesting parts to fit the part of the drawing we're interested in. And this is called pitch circle diameter, PCD. So they were my two criticisms. The other criticism I have is that, otherwise a very good drawing, is that the hatching is too dark. This hatching should be light. Now, that I went into the Australian Standard to look for that, to see where that's specified. And the fact is I can't see it specified, but it's demonstrated in that if I look at this drawing here, I can see that my hatching is lighter. And if we keep going up, I can see that my hatching is lighter. Even though it's not specified in words, I can see that my hatching is lighter. So that's not an Australian Standard drawing. Okay. So again, we can see, we're going to learn about hatching as per the Australian Standard. Again, we can see that it's lighter. Okay, so the idea is that in the Australian Standard, ideally what we want to try and cut through the interesting parts. So if there's a hole, we want to cut through that, right? We want to cut through that where it's interesting. The sectioning should usually be at 45 degrees, or if the object is, 45 degrees wouldn't be useful, then we're allowed to change the angle, as we can see here. If we have two materials, we should use alternate hatching. So if we have three materials, we can do this one at 45 degrees, or sorry, this one here is at 45 degrees, this one's at 60 degrees or 30 degrees, and then this one is done at a closer spacing so that we can differentiate that there's three different materials in contact. I would always specify that you should try and have your spacing wide. I think 10 mil is great spacing, because the wider your spacing, the less you need to do. And that we're worried about speed, so 10 mil is a great spacing. If you feel as though 10 mil won't show enough information, by all means you can vary it, but 10 was where I'd recommend. Okay, so if we have two different materials, we can see here that we should change the direction to show two different materials. This is correct, this is incorrect. So we can see some other things here where, unfortunately, these are on the side. We can say we usually want it 45 degrees, not an angle like that. That's confusing. And we can rotate it where it would be confusing. So this is also incorrect. Now, when I talked about how we always go through the interesting parts, when we do our section should zigzag along the interesting parts. So it's important that they zigzag along the interesting parts. Now, you can see here that when we've gone through this section here, it's very thin. This section's cutting through. That's called a web. And when we have webs or flanges or other small sections, we should differentiate how we show them. So here we can see we have different kinds of hatching, but generally in the HSC, most people will tell you that we shouldn't hatch it at all. We should just leave it empty. And I'm going to tell you for the HSC, we just don't do it all. So here again, we have another interesting shape, and we have ribs that are stiffening the thing, but obviously those ribs are much thinner than the rest of the drawing. So what we've done here is we've gone through the interesting circle, we've gone through the rib, and we've gone through the rib, and then through the circle, so that the resultant looks like this. It looks symmetrical. We didn't hatch the web, or we didn't hatch the rib. We left that blank so that people will look at that and say, what's going on there? And they'll look at the drawing and say, oh, that's only a thin section. And we don't have drawings that look like this. Not only is that way more difficult to draw, but it's also very confusing to read. So don't just literally cut the thing in half, because if we cut the thing in half like we might want to, right, cutting the thing in half is going to create really difficult drawings for us. We're going to have only a little bit of the rib. Here they've sectioned the rib as though it's a much thicker section. So don't do that. This is bad. Don't do this one, right? And so that is specified in thin sections. Relatively thin elements is where it specifies. Okay, so that's now this is this is advanced communication. So this is getting further to the end of the course, or not to the end of the course, certainly to the end of year 11. And then, so this is another example of, I don't know if this was a HSC question. I think this might have been a trial question on PCD. The idea that when if they tell us to section this thing, even though the section line cuts through A, the fact that they've said above PCD, pitch circle diameter, means that you should rotate this circle along. Because they wrote those three letters PCD, it means rotate that circle along. It also has this symbol here, a spot face. A spot face just means that the area is sunken. The area is sunken. And we also talked about how webs can be PCD. In addition to circles being PCD, webs can be PCD. So that's some notes there. Okay, this is the big finale, right? So I said that often there have been 6-mark questions on drawings. This is a drawing from 2018, and I have the 2017 question as well. So what they've said is, we want you to draw this drawing. We want you to do a half section, which a half section means we want you to cut away 1/4. And we want you to show us what it would look like if you sawed through 1/4 and just removed 1/4 of the thing. And I'll show you what the answer looks like. It looks like that. Now, the point is that most people would say, but we didn't drill through those, we didn't cut through those holes, right? We didn't cut through those holes. But because they're the interesting part, we should move them up. Rather than having hidden detail, we should move them up. And so that's what we're looking at here. I would say that maybe I would make the lines a little bit lighter for the sectioning, for the hidden detail. For the hatching, but it is noticeably different. So that's enough. More than anything, I can see a difference in the line width. The person who's drawn this has at least known that the center lines need to be lighter. So that's the sort of thing that we're drawing, and that's 6 marks of your HSC. They've shown that this is threaded by showing this line here, rather than drawing a zigzag, and there were definitely kids who would have drawn zigzags. That's what we do instead. And if we look at the 2017 question, it looked like this, and the answer was that. Now this one here, I think that their thick dark lines were a little too thick dark. This definitely should have been thick dark, and I think this one should probably have been thick dark, and even this should have been thick dark on the outsides. But it gives you an idea of what is expected for these drawings. So, and I'm pretty sure that one was also worth 6 marks. Yep, it was. So you would have had, well, times 1.8, well over 10 minutes to do that question. So, yeah. Okay, so that will do for drawing standards. Okay, before I finish, so here I have a brick, and I like bricks. I think bricks are a great example of how we do drawing standards. And in this brick, you can see that this is how I've done my sectioning. That if you cut through this brick along this line here, along line A, you would get a shape that looks like that down the bottom. The only other thing I'll point out, and there was a question a few years ago, and I was quite embarrassed when I got this wrong, is that a cutting plane, the area where we demonstrate the section on our drawing. So where we show there's a section, we draw a line to say, hey, this line here, this is where we're going to do our cut. So if I call this section AA, then I would draw a line AA. So I'm saying between this point A and that point A, that's my section. This should have thickenings on either side when we draw a cutting plane. They should have thick areas on the outside. And I'll say I was embarrassed that I got that one wrong when I was telling my students at one point last year. But at least we learnt together from that HSC, and we don't make the mistake anymore. If we look here, so we can see, do you see how we go through the interesting parts? And can you see how we thicken the line? And that's our cutting plane. We can thicken the outside parts. The arrow shows us which direction we're looking at. And here again, we can see our thickened lines, and these are our section lines or our cutting plane. And that's where we're showing where we're cutting through. So here, do you see how they label this as section AA? It says go from A to A, that's section AA, and this is section BB. And that's a very common way that engineers will specify sections. Okay, we're done. I said we're done. I'm just going to quickly say that we will talk about engineering reports, but I'm not going to go through engineering reports in this video. Now we're done for realsies.